Hello everyone, myself Kaushik, working as Assistant Professor in EC Department from MLR Institute of Technology, Hyderabad. In today's session, we're going to cover about BCD subtraction using complement method. Complement method means R's complement or R minus 1's complement method. In previous session, we already discussed how we are supposed to perform BCD subtraction. In today's session, we will cover the BCD code subtraction using the complement method. Firstly, BCD code means binary coded. We already discussed this. I'm just trying to revise the concept. Binary coded decimal, where each digit of the BCD code is represented with a 4-bit binary equivalent value. Okay, that means each and every single digit is represented with its 4-bit equivalent value. So here we are trying to perform BCD code subtraction using the complement method, which can be performed using the R's complement and R minus 1's complement method. As we're talking about BCD code and the base of the decimal number system, that is 10, where R indicates radix or base. So we can able to perform subtraction using the tens complement method. And the tens complement method are R minus 1. R minus 1 means 10 minus 1's complement. That leads to what? 9's complement method. Okay. So let's solve a problem. How we are supposed to perform the subtraction using the complement method. So here the question was given like perform the BCD subtraction for the following numbers using the 9's complement. Okay, we will try to do it in the 10's complement also. Try to check out the result. Okay, first let's try to represent each and every given number in the BCD value. Then we are supposed to perform the subtraction using 9's complement method. Okay, first given value, that is the minuend, and this is called as subtrahend. So we are supposed to perform subtraction using 9's complement. Indirectly we are trying to perform like m plus of minus s. Let's try to represent minuend value in terms of BCD value. So it is given as 305.5, right? So let's try to represent that value in terms of BCD. BCD means each and every digit should be represented in a 4-bit binary equivalent value. So 3 can be represented as 0011, where 0 can be represented as 4 zeros, 0, 0, 0 like this, and the 5 can be represented as 0, 1, 0, 1 and the decimal point. Then afterwards it is given as 5, so it is again 0, 1, 0, 1. Okay, and this is the equivalent value for the given minuend. Okay, now let's look at the subtrahend. We are supposed to represent the subtrahend in its 9's complement. So subtrahend is given as 168.8. Okay, for that you are supposed to get the 9's complement. So subtract each and every digit from the highest possible value, that is 999. Highest possible value of the number system. BCD highest possible value of the number is 0, and its range starts from 0 to 9, and this is our highest possible value. To get that 9's complement, you are supposed to subtract each and every given digit, supposed to be subtracted from the highest possible value. So 9 minus 8, it will be 1, and again 9 minus 8, it will be 1, and again 9 minus 6, it will be 3, 9 minus 1, it is 831.1. This is a 9's complement for the given subtrahend. Now we are supposed to represent that 9's complement of 831.1 in terms of BCD value. Okay, let's try to represent that 831.1 here. Okay, I'm trying to represent this value. 831.1, 8 is 100, that is 8. Next 3, 0011. Next after that it will be 0001, and it is equivalent of 1, right? Next again 1, that is 0001. Right, now we are supposed to perform the basic BCD addition. So 1 plus 1, it will be 1, 0. 0 plus 1, basic binary addition, 1, 0, and 1 plus 0, it is 1. 0 plus 0, it will be 0. Okay, 1 plus 1, it leads to 1 carry, and here the resultant sum is 0. 0 plus 1, it is 1. 1 plus 0, it will be 1. Then afterwards 0 0, it will be 0. Let's look at the next group. And 0 plus 1, 1. 0 plus 1, and again 1. And 0 plus 0, 0. 0 plus 0, it will be 0. 1 plus 0, it will be 1. 1 plus 0, it will be 1. 0 0, it will be 0. 0 plus 1, it will be 1 0. Now if you observe the resultant sum, it is generating some kind of invalid code. In case of BCD code, this 1011 is a invalid code. It is a invalid code. So whenever you're performing subtraction or the addition, if it is generating an invalid code, you're supposed to add. Right now we are performing addition and it was generating a invalid code 1011. For this respective code, you are supposed to add 0110 to make it as a valid code. We already discussed how we are supposed to do or convert the invalid code into a valid code in the last session. Okay, so currently I'm adding 0110 to the invalid code. In the rest of the values, just leave it as it is and copy the values just like that. 0011. Now here 10, it is 1. 11, it is 0. 11, it is 0. 11, it is 0. You can observe that after adding this value, it is generating a carry value. Now whenever it is generating carry, in terms of when we are performing r minus 1's complement, if it is generating carry, simply add this carry to the least possible digit key. For that you are supposed to add it. Now simply add this carry here so that we will get our correct result. Okay, 0 plus 1, 1, and again 1, and again 1, and again 0, and the remaining values are 0, 1, 1, 0, 1, 0, 0, 0, 0, 0, 1. Okay, and the resultant value will be like 136.7. 136.7. This is your resultant value when you're performing BCD subtraction using the 9's complement for the 305.5 minus 168.7. Even you can also check it out by performing the regular subtraction, like 305.5 168.8. Okay, like what exactly they mentioned, BCD subtraction. For example, if you're representing the BCD value as it is, even if you're performing directly also, what is the value here? What's the value? 5 minus 5, we can't perform 5 minus 8, so you're supposed to take a borrow, and the borrow value is as equals to decimal value, so it is a decimal number, so supposed to be represented, and the borrowed value as equals to the base value, that is 10 plus 5, 8. 10 plus 5, it is 15. 15 minus 8, it will be 7. The remaining value here, it will be 4. So we cannot perform subtraction, so you are supposed to borrow some amount of value from here to here, and here the borrowed value is as equals to 10. Here you are taking the borrow again, and here it will be 10, and here it will be 9. So 10 plus 4, it will be 14. 14 minus 8, it will be 6. And again here the remaining value is 9. Here the remaining value is 9. 9 minus 6, it is 3. Here it is already taken one borrowed, so that means the remaining value is 2. 2 minus 1, it is 136.7. You can compare both the values. 136.7. Now let's try to do the same kind of problem in tens complement. Okay, like it is 305.5 minus 168.8. right, 305.5 minus 168.8. so we already performed 9's complement, right? We already got the 9's complement. For this value, if we add additional 1, then we can able to convert that into the value into a tens complement value. So simply for this generated BCD code, we add LSD. For that LSD, if you add 1, then it will be converted into a tens complement value. Okay, so simply 168, 1 second, 831.1, right? Okay, for 168.8, its ninth complement is 831.1. Its ninth complement value is 831.1. For this, simply add 1 here, it becomes 2, and it will be 1, 3, 2. 831.2. For that, for this 831.2, you are supposed to add, you are supposed to represent in terms of BCD code. 305.5 already we have represented, so I'm directly writing that value here. So simply 305, that is 0011, and again 0, it is all zeros, all 4 zeros. Then afterwards it is 0101, and again 0101. Next 168.8, that is you are supposed to represent this 831.2, right? So 831.2, 1000 30011. Next of 1 it is 0001. Next it is 0.2. 0.2 means again 0010. Now perform the BCD addition. So let's perform BCD addition for the converted values. So 1 plus 0, it will be 1, 0 plus 1, it will be 1, 1 plus 0, 1, 0 plus 0, it will be 0, decimal point. Then after that 1 plus 1, it will be 1, and 0, it will be 0 plus 0 plus 1, that will be 1, 1 plus 0, 1, 0, 0, and it will be 0. Next value 0, 1, 1. Okay, 0 plus 1, 1, 0 plus 1, 1, 0 plus 0, 0, 0 plus 0, again 0, 1 plus 0, 1, 1 plus 0, 1, 0 plus 0, 0, 0 plus 1, 1. You can observe that it is a invalid BCD code. For that invalid BCD code, you are supposed to add 0, 1, 1, 0. Simply add remaining value supposed to be, remaining group value supposed to be copied as it is. So 0111 dot 0110, and again 0011. Then the value 1 plus 0, it will be 1 plus 0, it will be 1, 1 plus 1, it will be 1, 0, 1 plus 1, it will be 1, 0, 1 plus 1, it will be 1, 0. You can see this carry, this is our generated carry. If carry is generated, then the resultant sum will be considered as positive, and in case of OR's complement, method, if there is any carry generated during the subtraction, the carry was supposed to be discarded. Once it is discarded, the remaining value will be only this value. If you write this equivalent BCD value, decimal value 0001, it will be 136.7. You can check with the previous problem, that is we solved in case of 9th complement, that is also as equals to 136.7. Right now you are performing with respect to the 10th complement using 10th complement method. Still we are getting the same kind of answer. Thank you. In our next session, we're going to discuss about XS3 code and its addition, subtraction,